Assalamualaikum and hi everyone. In this video, I will show you how to answer the tutorial question first hour week 5 for the topics of electrochemistry. But before you watch this video, I hope all of you already answered the questions or at least try to answer the question. Before we go to the first question, we look at the overview for these topics. We have 3 subtopics that will be discussed, which is galvanic cell, Nernst equation, and electrolytic cell. But in this video, it is only related to the galvanic cell. As you know, the galvanic cell, we have 2 electrolytes with 2 electrodes dipped into the electrolyte. For the galvanic cells, the electrode must match with the electrolyte used. For example, if I use zinc electrode, I have to use an electrolyte with zinc ion. Same as this electrode, if I use copper electrode, the electrolyte used must contain copper ion. And this is the illustration for the galvanic cell. We have salt bridge to complete the circuit or to connect both electrolyte. We have voltmeter. The anode is negative terminal while the cathode is positive terminal. Let's have a further look on the galvanic cell. With the idea of oxidation always occur at anode and reduction always occur at cathode, we can know that electron will move from anode to cathode. In the galvanic cell, you have to know how to read the standard reduction potential or use the standard reduction potential. If the value of E naught is more positive, so that electrode will be cathode. From the standard reduction potential, we will have the E naught value at anode, and we can write the half cell equation and also can state the observation that occur at anode. Same as what happened at cathode electrode. From the information that you get from the SRP value or SRP table, we can use the formula of E naught cell equal to E naught cathode minus E naught anode. Take note that E naught, not here, means the reaction occur at 25 degrees Celsius at pressure 1 atm and the electrolyte with the concentration of 1 molar. So, when we already have half cell equation at anode, half cell equation at cathode, we will able to write the overall equation and write the cell notation, and we can know the value of N, which is the number of electrons from the overall equation, and also the Q value. Q can be calculated using the formula concentration of product over concentration of reactant. Next, we can use the Nernst equation, which is E cell equal to E naught cell minus 0.0592 over N log Q. From the E cell value, we can know either our cell is spontaneous or non-spontaneous, where if we get E cell positive, our cell is said to be spontaneous cell or spontaneous reaction, while if our E cell value has negative value, it is called as non-spontaneous cell. This is standard reduction potential that we are going to use in this topic. If we look at the standard reduction potential or SRP, we can see that the zero value here, and it is what we call as standard hydrogen electrode or SHE, or I will call it SHE to make it easier for me to explain to you. By using the formula of E naught cell equal to E naught cathode minus E naught anode and relate with the SHE value, we can calculate the standard electrode potential for the electrode in our galvanic cell. Let's have a further look on this cell. If you look at this cell, we connect SHE, this is hydrogen electrode. Hydrogen electrode is hydrogen gas with platinum as our electrode. This is our platinum. And acid electrolyte. In this diagram, we use HNO3 as our electrolyte. When we connect this She with another electrode, we can have a value of voltmeter. In this cell, She acts as cathode, so it undergoes reduction. When She acts as cathode, this other electrode will become the anode, and the oxidation will occur here. From the formula of E naught cell equal to E naught cathode minus E naught anode, we can apply the formula of E cell that we get from the voltmeter here and the value of She, which is equal to 0, to find out the E naught anode or the standard electrode potential for zinc. By performing the calculation, we can have the value of E naught anode or E naught zinc as negative 0.76 volt. This is when our She become as anode. So when She become as anode, She will undergoes oxidation. When She undergoes oxidation, it will produce H+. When She undergoes oxidation, means it acts as anode and this acts as cathode. And by applying the formula of E naught cell equal to E naught cathode minus E naught anode, we substitute the value of E naught cell, which is equal to 0.8, into the equation, and the value of She, which is equal to 0, into the equation. We can know the E naught cathode for this cell. So we will have positive 0.80 volt for E naught cathode. Now let's start with first tutorial question. The magnitudes of the standard reduction potentials of two metals X and Y are as follows. E naught denotes only the magnitude, not the sign of the E naught value shown. When the half cells of X and Y are connected, electrons flow from X to Y. When X is connected to She, electrons flow from X to She. Now let's find a clue in this question. When electrons flow from X to She, it means that X is an anode while She is cathode. You must always remember that electron will always flow from anode to cathode. So X as an anode, it will undergo oxidation, and with the idea that E naught more positive will become cathode, and we know that She will have the value of 0.00 volt. So E naught for X2 X must be smaller than 0, so it will be negative value. Now let's prove it by the calculation. We know that the formula of E naught cell equal to E naught cathode minus E naught anode, and the value of E naught X 2 plus X is equal to 0.25 equal to E naught cathode 0 minus E naught anode. And we will get E naught anode equal to negative 0.25 volts. So it has negative value. Second one, we know that electron flow from X to Y when X is connected to Y. So in this case, X still become an anode as electron flows from X to Y. So X undergoes oxidation, and X will have more negative value of E naught compared to Y. Thus, when we compare the value 0.25 and 0.34, so that 0.25 be more negative, Y must have positive value. And as a conclusion, E naught Y2 plus Y is equal to positive 0.34 volt. So we have settled for the first question. Let's move to the next question. Calculate the standard EMF of a cell consisting of X and Y electrodes. By using the same formula, E naught cell equal to E naught cathode minus E naught anode. And we already know that our Y as cathode, X as anode, and we just substitute the value, we will have E naught cell equal to positive 0.59 volt. Don't forget to put the sign of positive and also the unit, as it is the correct way to give your final answer. Let's look at question number 2. Predict whether the following reactions would occur spontaneously in aqueous solution at 25 degrees Celsius. Assume that the initial concentrations of the dissolved species are all 1 molar. So, the question asks you to predict whether the reaction would occur spontaneously or not. So, we have to know that the reaction is said to be spontaneous when our E cell is more than 0 or it has positive value. First, we have to identify from the overall equation which is anode and which is cathode. Let's look at question A. From the overall equation, we can see that Ca solid has become Ca2 plus aqueous, indicates that Ca undergoes oxidation, and this will be the reaction at anode. Cd2 plus will produce Cd solid, which means that Cd2 plus undergoes reduction and indicates that it is occur at cathode. So, by applying the formula E naught cell equal to E naught cathode minus E naught anode, and by referring to the standard reduction potential table, so we have the value of E naught cell at cathode and E naught cell at anode. And just substitute into the formula, we will have E naught cell for reaction A is positive 2.47 volt, indicates it is spontaneous reaction. The same way you will apply for the question B, C and D, and you will have B as non-spontaneous reaction, C as non-spontaneous reaction, and D as spontaneous reaction. The third question, choose which species in each pair is a better reducing agent under standard state condition. Let's look at sodium or lithium will be a better reducing agent. So we have to refer to our SRP table. We have to refer to the value of sodium and lithium. But in the standard reduction potential, you will refer to the reduction of Na plus to Na and Li plus to lithium. Strength of oxidizing agent increase up while strength of reducing agent increase down. By refer to these two values, we can know that lithium has more negative value, so it has become the more or better reducing agent compared to sodium. Same goes to H2 or I minus. We will refer to our SRP table or the value of E naught cell, and we can see that H2 has more negative value or increase down, so it is better reducing agent compared to I minus. Now let's look at this question. Standard electrode potential for Ag plus Ag and Pb2 plus Pb are positive 0.799 volt and negative 0.126 volt respectively. Determine the anode and the cathode and calculate the standard cell potential. This is the idea to determine which one will be your anode and which one will be your cathode. Anode with more positive value will always become the cathode. So from these two values, we can have our Ag plus Ag with a more positive value, and means that Ag plus will undergo reduction. So our cathode will be silver or Ag, while our anode will be Pb. Second one, to calculate the standard cell potential, as we know the formulas, E naught cell equal to E naught cathode minus E naught anode, we apply the formulas, we will get this answer, positive 0.925 volt as our E naught cell. Next question, for the reaction 2Ce4 plus CO produce 2Ce3 plus CO2 plus, the standard reduction potential for CO2 plus is negative 0.28 volt. Calculate the standard reduction potential for the change of Ce4 plus to Ce3 plus. So for this equation, we have to identify which is anode and which is cathode by looking at the reaction given. This is 2Ce4 plus. It will produce 2Ce3 plus, indicates it undergoes reduction, so it is our cathode. While CO solid, it will produce CO2 plus, indicates it undergoes oxidation, and it is as our anode. The standard reduction potential for CO2 plus is already given, so we have to apply E naught cell equal to E naught cathode minus E naught anode, and we already have the value of E naught anode. Just substitute into the formula and we will get the final answer equal to positive 1.61 volt. The next question, given to you the cell potential, show a balanced equation for the spontaneous reaction in the cell, determine the oxidizing agent, and calculate the E naught M3 plus M. Given to you, E naught Ag plus Ag equal to positive 0.80 volt. Okay class, this is what we call as cell notation, and the cell notation is notation of reaction in anode. This is our salt bridge, and at this side is the reaction that occurred at cathode electrode. So when this is anode, so we can have our first half equation or half equation at anode. Ag solid produce Ag plus, while at cathode we have M3 plus aqueous plus 3 electron produce M. When we combine these two half equation, we will have overall equation. This one we have to times 3. Before we combine the half equation, we have to make sure that our electron has the same value, so we have to multiply with 3 for the anode equation, and we will get this as our overall equation. You have to put the sign or the symbol of solid, aqueous in the equation. The second one, determine the oxidizing agent. Oxidizing agent is the one that undergoes reduction. So from the overall equation, we can see that M3 plus will undergoes reduction to produce M. So M3 plus is our oxidizing agent. And the last question is to calculate the E naught M3 plus M. We already have the E naught cell for this cell. Just apply the formula E naught cell equal to E naught cathode minus E naught anode. And we already have our E naught anode. And we just substitute into the formula. And finally, we will get our answer of E naught M3 plus M, which is positive 1.8 volt. The next question, predict whether Fe3 plus can oxidize I minus to I2 under standard state conditions. Okay, in this question, first we have to refer to our E naught value from the SRP value. So, if you find in the SRP table, you can find from the equation of I2 plus 2 electron produce 2I minus and Fe3 plus electron produce Fe2 plus. This is the reduction equation. Okay, that's why the name is standard reduction potential. So all the equations in that table are reduction equation. And this is a value of E naught. From the value, we can determine that this cell will become our anode as it has more negative compared to this cell. So this one will be our cathode. Now we want to predict whether Fe3 plus can oxidize I minus to I2. The word can oxidize mean the other words, it means that can Fe3 plus be an oxidizing agent. So if Fe3 plus as oxidizing agent, so it will undergo reduction from the value of standard electrode potential for both equation. So our Fe3 plus has more positive value, so it will become our cathode and undergoes reduction. Now we want to prove it by use this formula. We just substitute into the formula E naught cell equal to E naught cathode minus E naught anode, and we will get the value of positive 0.24 volt. Positive value means it is spontaneous reaction, so it proves that Fe3 plus can oxidize I minus. Okay, that's all in this video. If you have questions, you may leave a comment, consult me, or ask your lecturer immediately.